Greetings everyone, Rio Grande fan back here again with another ESU LokSound tutorial video. This time I'm going to discuss the new LokSound 5 decoders and how I set them up with my locomotives. And this video has been requested by several friends, and I hope all of you can get some benefit from it. The video does kind of center on using the LokProgrammer itself, although it's not completely required. No matter if you use the LokProgrammer or not, having the software is very helpful. So we can go through. I'm going to show you kind of how I set things up, and then if you don't have a LokProgrammer, you can do everything with your DCC system. It's a little more time consuming, but it does work. So the first thing you want to do, whether you're a beginner or if you've already downloaded previous versions of the software, is just to make sure that your software is current. So to do that, go to the ESU website by typing in loksound.com. It's LokSound.com, and it will change to this URL here. You can also type that in if you want. Once you get to this page, I want to click on Downloads, then Firmware and Software, and then LokProgrammer PC Software. This software does only run on Windows machines, and it's the first one listed. If you do have a Mac, there are some emulators and some other ways you can get around it, but primarily it does run on Windows. The current version is 5.1.0, and it's always going to be the one posted at the top is the current one. So if you don't have that version, go ahead and download it, and it will update your previous versions. Download, and then hit download. It'll save it to wherever you save your files. Generally, that's the downloads folder, and you'll have to extract it and then open it. If you already have a version of the LokProgrammer software installed, it'll ask to update. Say yes, it'll update the software. If you're installing it for the first time, tell it where you want it to install it, and it'll install it. Once you've gotten that, at the end, it'll ask you to open the LokProgrammer software. Uncheck the box and then close the software installer. You don't want to open the LokProgrammer software directly. You always want to open sound files directly, and I'll show you why in just a bit. But since we're here, I want to show you where you get to the sound files. So we can hit Downloads again, Sound Files. You can click either one of these two links to get here, and you'll get to this page. If you're in the United States or Australia, you'll want to click here for the North American or Australia sound files for the LokSound 5. If you're in Europe, your files will be up here. Some of the factory equipped files are posted as well for the North American side here, Australia here, and European will be up top. Since I'm in North America, I'm going to click on this one, and it'll give me the list. There's 120 sound files as of today. These are all mixed up with Steam and Diesel. If you're only Steam, you can click on the Steam button. It'll give you only Steam sound files. If you're Diesel and your Diesel files, there's about three electric files, so forth. If you're looking for specific files, since these are in no particular order, you can type that in up here, and it will find your file, such as S0508. I know is a file, so it'll find it. You could also, I have to go back in to do this because it screws up the search, but you could also type in a prime mover, say 645, and it'll give you all the files that come up with 645 prime movers. And it may find files that don't fit, but it's going to primarily give you the ones that have some sort of 645 somewhere in the description. And you can find the one you want. If you want to be more specific, you can do that. If you're looking for a 567, it'll come up with those. If you're looking for a GE, you'll find all your GE files. So there's different ways to find what you're looking for. Again, once you find the one you want, click Download, click it, and then Accept and Download. It'll download the sound file. And then you can open it directly. So now that we're done, I'm going to close this, and we're going to go into where I have my files. We're going to open up S0508 directly, and it's going to open directly in the LokProgrammer. Reason for doing this is that later when you get down here to the function mapping window, you will actually get names for everything rather than sound slot 1, sound slot 2, sound slot 3 that don't mean anything to you. Having the names, now we know what's here. If you open up the LokProgrammer software directly, you're going to get lost. So always open up the sound file for whatever locomotive you're working with. If it's an SD40 or an SD70 or a GP38 or a cab forward or whatever it is, you want to have that file. If you're working with an OEM from anybody, try to get their file. Whatever manufacturer it is, if they use ESU, generally they should be able to give you the sound file for their locomotive if they don't post it on their website. That way you have a starting point. You now can open this up and you have a starting point. So we're going to go in here and I'm going to try to run through this somewhat quick to keep this video short. I'm already running pretty long. So let's start at the address. Why do people insist on setting this first? There's no reason to do this. I know a lot of people just love to set the address first thing out of the gate. Absolutely not necessary. While we're setting this up, it's certainly fine to leave it on 3. No reason to change it. Do this last. The reason I do this last is because if I ever have to do a decoder reset, CV8 to 8 by the way, I want something to change. I want there to be an acknowledgement that the reset worked. And the easiest thing to have change is the address because it's easiest to put back to the cab number. I can change everything else in here and set them as defaults, but I don't want the address to set as a default. So I leave it 3. And what I mean by setting it as a default is once we get going through here, we're going to be clicking on the Write Decoder Data button, which is going to bring up this window. And this window has a checkbox for overwrite defaults with current values. So whatever we change in here is going to become the new default that the decoder will reset to if we have to do a decoder reset. I don't want my cab number doing that because then nothing changes in a reset. So we would uncheck the box before we write the address. So we're going to skip this page. We'll come back to it later. So in the analog settings, if you're running in DCC, you don't need analog turned on. There's absolutely no reason to run a decoder equipped locomotive on DC. So we turn that off just by unchecking that box. Everything else on this page is related to DC operation. We don't care about. We're going to just leave it like that and move on. If you want to write every one of these pages as we go, you can certainly do so by coming up here, making sure this is checked, and say next, and it'll make this the new default. Again, because the address stayed on 3, we can do that. Alright, let's keep going. Brake settings, I don't really mess with this page. There's one thing to note at the bottom of this page is the brake functions. So there's 3 brake function logics in the decoder, and you can change these if you want to or as you need to reduce the brake time and the maximum speed when the function is active. This is mostly used when you're working with the proto throttle and you're trying to dial in the brake handle, or if you're trying to work with a brake function on your throttle. You can mess with these and get the engine to either brake sooner or brake not as quickly based on the activating of that function. And that's all. We'll show you the brake functions in the function mapping. See, here's brake 1 for the independent brake, brake 3 is the dynamic brake, and then brake 2 is an automatic brake down here, which doesn't really, it's hard to trigger on F30 because I don't think other than ESU systems you can't get to F30. But anyhow, that's what the brake 1, 2, and 3 mean. And again, it's out of the scope of this video, so I don't mess with these initially. You can come back to it later. Compatibility. If in your sound file this is checked and this little triangle warning here is here, just uncheck this. We don't need it. SUSI is used in Europe and it's not used in the United States, and so it's out of the scope of this video. Someone else can do an SUSI video if they want. I'm not going to do it because I don't use it. So we're going to skip that. This one here is Railcom. If you use an ESU ECOS, or you use an ESU cab control system, you'll want to leave Railcom turned on so that it automatically reads the decoder into the system. If you use NCE, Digitrax, somebody else's CVP, any other DCC system, this is not going to mean much to you, but it doesn't hurt you to leave it on either. Speed step mode, just leave this the way it is. Detecting it automatically sometimes leads to issues, so I would just leave it the way it is. That way you're always using 28 or 128. 14 speed steps are really not used anymore, and all DCC systems today can handle the 28 or 128. If we come in here to the acceleration and deceleration rates, CV3 is the acceleration, CV4 is the deceleration, and they've also added an adjustment here. So you can actually, if you increase this number higher than 0, now you can add to it. So if we increase this, you can now add to it. So now these two add together. If you decrease it, they will subtract. And I believe you can somehow manage to get below 0, but I don't know how exactly that would work. I don't recommend setting these to 0 because you don't want your locomotive to jackrabbit start and jerk to a stop. Leave a little bit of momentum in, even if you don't like momentum. Leave these settings down at around 4 or 5, so just so you have a little bit, so they don't just automatically just rocket to a start and halt to a stop. A little momentum is good, and you do have to get used to it. Plus, if you add a little bit more momentum in, your sound is going to be a little more realistic. Real trains do take a little while to get moving, and they obviously take a long time to stop, so you just have to kind of get used to it. And I know that's a little tough when you're doing switching, but anticipate your moves maybe a little bit better. I don't know, but just kind of play with that. Trimming, I'll skip reverse mode. We don't really need this. If you wire your decoder properly, you don't ever need this. This is all it's doing is kind of a cheat to flip your direction in case you miswire your decoder. I don't recommend cheating this way. If you miswire your decoder and it runs in reverse when it's supposed to run forward, just reverse the motor wires. It's far easier, far better to just reverse the motor wires. Don't cheat with this. Trimming, forward trimming. This is in the forward direction only. If your locomotive runs too fast compared to another one in a consist, for instance, and only in the forward direction, you want to slow it down, then you can come in here and you can slow it down just in forward. If you want to slow it down in reverse, you can do the same thing here. And why do I go just directly to slow it down? Well, it's very difficult to speed up a slow locomotive. I have found that doesn't really work. A slow locomotive generally is going to run slow. It's not going to run much faster than what it's running. So changing these above 128 doesn't do much. You can play with it if you want, but my experience, it doesn't really do much. Trim, when switching mode is enabled, there's a switching mode that halves the speed when you're switching, and you can play with the voltage here. And you can see how it halves the voltage. It's also, I believe, going to have the acceleration. I think there's a way you can do that as well. So if you set these really high when you're running your train down the main and you want to have it for the switching, I believe there's a way you can turn that on so that you can be more, it'll be more responsive when you're switching. Load adjustment is, there's optional load and primary load now built in. Again, I don't mess with these by default. This is more of an advanced feature you can come back to. If you can get it more into the proto throttle or more into advanced, want to play with the load and really ramp up the prime mover and things like that. In fact, primary load really is kind of an independent of speed. It's a new thing I haven't really played with much. It works more automatically independent of speed. I'm going to have to play with it a little more, but at this point you can bypass it. Gearbox backlash I don't mess with. Yeah, I don't exactly understand what that means either, so we're going to skip it. I don't mess with it. Never had a reason to need it. Power pack, time to bridge power interruptions. So if you solder in a ESU power pack to your decoder, this is how long it will give your locomotive a boost, 4.16 seconds by default. There's really no reason to change this. If you have a dirty section of track or a dead switch, that takes longer than 4 seconds to get through, you probably should fix the switch or clean the track or the wheels or something like that. 4 seconds is quite a while, and you really don't need it to be any longer than that. In fact, I would shorten this value. I've seen a lot of issues with this. If you run in consist with the engines in the middle and the rear, and you have a short circuit or the power goes out, the locomotive will still run. And I've actually seen cars hit the floor. So you want to be very careful about this setting, and you want to set it just long enough to compensate for the issue you have. I know that the obvious thing to do is really to crank this up and watch your locomotive run for 8 seconds, but it's really not an ideal situation. Plus, the longer you set this, the higher the number, and if you drain it, it's going to take a lot longer to recharge. So then you know, if you need it again right away, the power won't be there. So you want to make sure that you kind of set this to a reasonable number, and I found that somewhere a little bit lower is better. I actually don't use power packs. My stance on these is they're not really needed in most larger locomotives. Yeah, they're needed in switchers, and they're needed on stuff that doesn't pick up power very well. But for the most part, you don't need a power pack. If your track is well wired and your wheels are clean and your locomotive or your track is clean, you really don't need these things. So try to run your locomotive first without one, and then only add it if you absolutely need to. They do cost a lot of money. They're $50 at retail, and they're kind of a band-aid. So only use them if they're necessary. Otherwise, it's much better, much cheaper actually to fix the track or fix the wheels or fix the power pickup in your locomotive than it is to add a power pack. Preserve direction we don't need to worry about. Starting delay, this is the starting delay if the drive sound is enabled. So this is the startup sequence time. So when this is checked and you press function 8, the locomotive goes through a startup sequence. And if you want your locomotive to move during the startup sequence, uncheck the box. I leave it checked because I do want my locomotives to run a little more realistically, and so therefore I leave it checked. I wait the 20 to 30 seconds generally it takes. Just like a real locomotive takes time to start up and warm up. I like my models to do the same, so I'm not just in a hurry to come down and start them up and then run down the track. Patience is a virtue, I suppose, but if you don't like it, turn it off. In function mapping, this is going to be where you're going to do most of your work. If I have a locomotive that has ditch lights, generally I model West Coast railroads. Most of them out here don't flash. So I just turn this off. Now there's some NS, CSX, Florida East Coast, there's some short lines, Amtrak, there's a whole bunch of other little things here and there where your prototype might have flashing ditch lights. If it does, leave grade crossing logic turned on with the horn. When you press function 2 to blow the horn, the ditch lights will flash. If your prototype does not have flashing ditch lights, which is the vast majority of locomotives out there, uncheck this and your ditch lights will not flash with the horn. If you just don't care, and you want it because it's cool, and it is cool, you can just leave it on. And rule number 1, right? It's your railroad. The rest of these are pretty self-explanatory. Coupler, F4 turns on the dynamic brake fan. This is just logic that runs the dynamic brake fan. Shift mode 1 brings the prime mover down to idle, waits about 10 seconds, and then runs it up to notch 4. The brake 3, that was that logic we saw earlier that makes the locomotive slow down over time. If you run the dynamic brake long enough, and I mean long enough, the locomotive will come to a stop, but it will take a long time. I think it's about 45 minutes. So generally most of us don't run our dynamic brake that long, so it's probably not going to ever stop on you. But if it does, I suppose you could come up here and brake 3 and max it out so that it doesn't brake, so it reduces the brake time by 94%. Anyway, I got to do some more studying on this myself, but for the most part, it just works the way it is by default. Function 5, I usually change this. I leave it on LOX 3 for the number boards. Emergency light is set to a rotary beacon effect, so it flashes, which is what a lot of, I've read a lot of this where you first put the file in and your number boards blink. So this is easily changed in the next tab here. If we go there, aux 3, we change it away from rotary beacon just to dimmable headlight. We don't want it to dim because number boards don't do that. And you can type in number boards. Whatever you type in here doesn't really matter. This is only for you. The decoder doesn't care. It's not stored on the decoder. So all these names are just for us humans. The decoder doesn't care. When you go back, now it says number boards. So now we know that function 5 is number boards. Function 6 is going to be your ditch lights if your locomotive has ditch lights. If it doesn't have ditch lights and you want a Mars light here or a rotary beacon here, or whatever light you might have here, you could remap this. This is wide open function mapping, so you can map anything to anything. I could put my horn down on function 22 if I wanted to. I don't know why I would, but it's open for that. So customize it for your locomotive. Most of mine do have ditch lights, so I leave these alone. If your aux 1 is something else, that's great. If you want it on a different function, perfect. Move it around. You know, if you don't use the coupler, for instance, and you want to open function 3 for something else, then you have the ability to do that. Just remember to turn off what you're not going to use, and you can do that just by dropping something down and unchecking boxes. It's very simple. One of the things I do is I change this drive F7. Drive means move, and function 7 is just the 7 key, so driving and 7 have to be on for the flange squeal. I like to move this to function 12 because I like the dimmer to be on 7, so we're going to just ignore the drive. We're going to move this to dimmer, and we're going to put this as off right there. So that's now the dimmer. I move it to 12, so we put yes, because we don't want the flange squeal to run when it's stopped. Would make no sense. Turn off the dimmer and put in sound select 23 for the flange squeal. Now that's on 12. A lot of DCC system throttles kind of end at 12, so you have 0 through 12. Then 13 through 28, and ESU has added these extra 3 in here that only are active on their systems. NMRA recognizes up to function 28. But you can get to these with shift modes or other ways in most DCC systems. You can still activate these higher functions, but they're not as common, so I tend to put things that I don't activate a lot here. You'll notice that rear ditch lights are on F13. Most of my locomotives don't have rear ditch lights, but if I had one that did, I would probably leave this here, or I'd move it somewhere else so it was a little easier, or maybe I'd even make it automatic. Real locomotives don't have automatic lighting. Everything's on a switch. So the front headlight and the rear headlight have separate switches. Ditch lights have separate switches. So everything's controllable by the engineer or the conductor. There's nothing automatic in a real locomotive. So I tend to set my locomotives up very similar to that, so that everything is not directional. Like I'd get rid of these forward and reverse, conditions, and so that just like in a real locomotive, I would be turning a switch. Function 0 turns on the front headlight. You do have to get a little creative with the rear headlight if you want it to work. Since I don't usually run my locomotives in reverse, I just get rid of it completely. If you ever do want to just get rid of a line, you can click the line and hit the X, and it'll delete everything on the line. So if I don't use my rear light, I just delete it. And you can leave this line blank, it doesn't hurt anything. But if you wanted to, you could kind of shore this up by clicking the next line. That's what these arrows do, move it up. So now it moves the line up. And if you wanted to move it down, you can move it down. So if I created an extra something in here, an extra condition in here, and I wanted it to be more in line up here, I could create it down here and move it up to where it fits. It's just a little trick of the function mapping table. Or if you wanted to restore defaults, You can restore defaults. Well, that didn't do what I expected it to do. That kind of messed us up there, didn't it? But yikes! That went to the German German defaults. So what I'm going to do is actually get out of this. We're going to not save it. So this is what happens sometimes. You just have to get out and not save and start over. Alright, we're going to go back in. Okay. I'm going to go ahead and make this change again so that I can show you how you would do this if you don't have a LokProgrammer. Dimmer. Because at this point now you could probably go in and write some of this stuff as defaults if you have a LokProgrammer. So we're going to add in yes, get rid of dimmer. If you missed this the first time, this is a great way to see it again. Alright, you can go up here to tools and then click show change CVs. It's going to give you a list of everything we changed. Some of this stuff went back to the default, but so CV31 stays at 16, so you really don't have to set it. You can if you want, but it doesn't matter. You don't have to do it. The next one you do have to do is CV32 to 3, and then you do CV385 to 0. So if you do these in order, it works out fine. CV32 to 8, and then these two CVs, then CV32 to 4, and then this one, CV32 to 9, and then these two. So CV32 is your secondary index, and that one really has to be set first before you do anything else. If you do these with your DCC system, you will mimic exactly what I did here on this chart. Pretty cool. If you have a LokProgrammer, you come up here, press the red arrow, make sure the overwrite button is checked, and hit next, and it will write these in about 10 seconds. Now it writes everything. It writes the whole thing, not just this window. It's not like JMRI where it writes just the window. But that's okay. As long as everything else is set correctly, like this is turned off, we didn't really do anything else anywhere else, so we're okay. Other than maybe this one. Putting this back there. And putting number board in there. I'm not going to, well, I'll go ahead and do it. Number boards, okay. Doesn't really matter. Okay, this is getting long. Let's move on. So in here you'll see front headlight, and it's on the fade in, fade out, which is what we want. So the light dims on and or fades on and fades off. Yeah, fades in, fades out. That's better. That's what it's called. Fade in, fade out. LED mode. Most of today's models have LEDs in them. And then the dimmer allows you to dim the headlight. If you uncheck this and you press the dimming function, the headlight won't dim. So this has to be checked in order for it to dim. Rear light, same thing. Ditch lights. This is a common issue. You always want your ditch lights set to type 1. Type 1 means that the light will turn on with a function. It'll be on solid. And then when you hit the horn, it will flash. And then after a time period, it will stop and it will stay solid. If you use type 2, they will turn off after they're done flashing. And I don't know of any locomotive that does that in the United States. Yeah, so anyway, don't ever use type 2. Just use type 1. But how do you get them to flash? So that's where you have grade crossing logic in LED mode. And then one of the two outputs, it doesn't matter which one, has to be set for alternate phase. So in this case, aux1 is off for alternate phase, and aux2 is on for alternate phase. So the alternate phase just means that the two are out of phase with each other, and then they will alternately flash. Same thing with the rear ditch lights on 4 and 5. They will alternately flash. Now how does it know which two to use? Well, that's back here in function mapping. We mapped both aux1 and aux2 to the same function key, and we mapped 4 and 5 to the same function key. So as long as they're on the same function key, it understands that these two go together. So when you press 6, both of these turn on, and then when you press 2 for the horn, they both flash alternately. Likewise, on here, if we turned on function 13, the rear ditch lights would turn on together, solid, and then when we hit the horn, they would flash. 4 and 5 would back and forth, they'd flash. If you wanted to be really weird and crisscross these somehow and put aux 2 down here, then 4 and 2 would flash. You get one on the rear and one on the front flashing back and forth. So whatever's together will be what flashes. I have noticed that if you do have front and rear ditch lights and you do have them both set to flash, they will flash at the same time. So if you don't want that, then you have to leave one of them turned off, I suppose. But there's no way to differentiate to just have one end flash at a time and leave the other end solid. At least not that I found. If you find it, let me know, but I haven't found it. So back in here, that's pretty much it. 7 and 9, just leave them on power pack control. If you do add a power pack, you'll need that. But everything else should be pretty self-explanatory. One thing I will mention, that if you don't have ditch lights, for instance, and you want to put in a Mars light or a gyro light, you do still have the ability to grade crossing logic. So what that means is you can essentially have the Mars light be on solid with a function key, and then when you hit the grade crossing or the horn, then the Mars light effect will flash. It'll do the Mars effect. Originally, when Mars lights came into F units and then later into hood units, that's how it was intended. The Mars light was only intended to be a grade crossing light, that it only was active during crossing a road. Well, it didn't last. The engineers ended up not turning it on or whatever, and it really wasn't automatic. The engineers did have to actually physically turn it on, and they'd forget. So a lot of them got lazy and they just turned it on. When they got in the cab, when they turned on all their lights, they turned on the Mars light or the gyro light, and they just left it on the whole time. So you can do that for sure. You know, that's easy, just to turn it on. If you wanted to have it to where it works with the horn, then you could put Mars light in here and then activate grade crossing. Then leave, of course, grade crossing turned on, and then the Mars or gyro light will work with the horn. In function settings, this is the blinking rate. So if you have flashing ditch lights, this is how fast or how slow they will alternately flash. Likewise, gyro light, a Mars light, a rotary beacon, anything that flashes will be controlled here by the blinking effects. For ditch lights, I like to do about 1 second or just under 1 second. If you have a Mars light or a gyro light, I like to do about 1.2 seconds. Again, this is going to depend on your prototype and your preferences. Trial and error, look at a video, time it out if you want on a YouTube video, it doesn't matter, but figure out how you want it set and set it to your preferences. 24 is mine for Mars and gyros, and about 19 or 20 is mine for ditch lights. The holding time is how long the light flashes after the horn or the grade crossing logic is turned off. So if I blow the horn and my ditch lights are flashing, they're going to continue to flash with the horn button off for 5.24 seconds. If I want them to flash for longer, increase the slider, less, decrease the slider. Pretty simple, not much to it. Sensor settings. These are wheel sensors and other outputs. This is for doing things like flange squeal or frog thump. There's sensors you can add to your trucks, sparking things, all these different sensors. We don't normally do that in the United States. But if you have a locomotive that has a sensor, or you want to add a sensor to your locomotive for some extra effects, that's kind of what that does. Automatic uncoupling is a European thing. It's kind of a neat function or neat feature we don't use in the United States, so I'm going to skip it. If we come down to random functions, this is kind of how they do it now. Random functions are now basically turning functions on. So the decoder is actually using the function mapping, and it's turning things on. So what we're doing here in random 1 is with the locomotive stopped, moving, driving, and the driving sound or the prime mover is turned on, function 11, which is the radiator fans, will randomly play based on these settings down here. So it's going to trigger function 11. Active means that the sound is on, passive means the sound is off. So active minimum, it's going to play for at least 5 seconds, but no more than 25 seconds. That's the max. So at least 5, but no more than 25. Now it might only play for 10 seconds, or it might play for 17 seconds. But it's gonna play somewhere in here. It has to play for at least 5, no more than 25. You can increase this value if you want to play possibly for longer, or if you want it to absolutely play for, say, between 1 second and 20 seconds, you can do that. Note too that if you want it to play for exactly 20 seconds, you make the sliders match, it'll play for exactly 20 seconds. Since the minimums can never be over the maximums, when you move this slider up and it equals, they're just going to stay equal. So now it's going to play for 30 seconds, or somewhere between 5 and 30 seconds. This is the off time, so after it's done playing, it's going to turn off. So it has to be off for at least 50 seconds, but no more than 150 seconds. So somewhere in here it will decide and it will turn on again. But it's going to be off for at least 50 seconds before it makes that decision to turn back on. But it will turn on before 150 seconds or by 150 seconds. Again, you can change this. If you want it to turn on sooner, lower this number. If you want it to wait longer before it turns on, increase this number. You can go to 255 seconds or down to 0. Again, maximums cannot be greater than minimums, so when you do that, the sliders move together. I like to kind of give a gap so that the decoder can have kind of a random choice between these numbers. And the rest of these just kind of just look at them. So 18 is the sanding valve, 19 is the short air let off, and so forth. The numbers change a little bit, but again, on time, off time, minimums and maximums. Alright, moving on. Identification. You can put any number in here between 0 and 255. So I like to put in the month and the year that I installed the decoders into the locomotive. So if I installed this decoder this month, I would put in 11 of 2020, and I know that I installed the decoder this month. If it was December, I'd put a 12. If it was 2021, which we all want to get to, I'd like to put in a 21. You know, maybe it's January and I'm installing a decoder, I'd put in 121, whatever. You can use this however you want, but I like to just kind of put in the year, the month and the year that I install the decoders, just so I kind of keep track. Manual CV input. Excuse me. Manual CV input just shows you every CV that's in the decoder. And this is the index, the first two, and then CV, the actual CV numbers, the values that are the defaults or the ones we change. Some of these we change, and that actually does change here. And then the binary value and the hex value. You can actually teach yourself binary and hex by looking at the actual values and then figuring out what the binary numbers mean and the hex numbers mean. It's pretty easy. Binary I highly recommend learning. Hex is not as important as binary, but you know, these are fun to learn. And you can see there's a lot of indexes. There's 13 indexes. Actually, there's 14 because 0 counts for CV32. And you'll notice that when CV32 is 0, starting at 259, CV31 stays 16 the whole time, and it defaults to 16. You never really have to set it to 1. I've never had an instance to set 31 to 1 or 31 to 0, so don't ever worry about doing that. You don't have to. Nothing below 259 needs to have an index. And then these here where it says 0252, I think this is all related to the SUSI stuff, so you never have to worry about this. It's kind of weird, but don't ever worry about it. So yeah, if you ever wanted to see what every CV was. So now at this point, you probably want to write everything as a default, everything we've made changes to. The reason I say that is because when we get to the motor settings, this is a pretty important tab. I leave the V-start, or I leave it as CV2, 6, and 5, V-start, V-mid, and V-high. I don't use the full speed curve. This is just fine for doing speed matching. I usually only mess with this middle one, and I get a really good match in about 5 to 10 minutes. If your locomotive jerks at speed step 1 out of 28, just increase this value until it doesn't. Generally, if you're going higher than 4, you're probably going too high. Values of 2 and 3 generally work really well. If you want to curb the top end speed, your locomotive runs way too fast, or if you're running a switcher and you want to lower it down to 15-20 miles an hour for a switching layout, bring this down and it will definitely plateau at whatever speed you want. And it's pretty consistent. I highly recommend doing that with a speedometer though, so you can be very accurate. And set these how you need. I usually don't mess with it too much unless I actually have to. And usually only when I'm doing speed matching. But at this point, what you'll want to do is actually put your locomotive on the track, set CV54 to 0. And yeah, you're still in address 3, but as long as you don't have any other address 3s on your main line, you're fine. Just set CV54 to 0 on the main, using programming on the main or ops mode programming, however your system does it. Make sure you have about 2 feet of track in front of your locomotive, and make sure it's set for forward, and then press function 1 or the bell. The locomotive will take off down the track, and then it'll stop, probably less than 2 feet. And if it's got sound, the bell will be ringing. If it doesn't have sound, it'll just stop. Turn off function 1, and then come back to your LokProgrammer and read decoder data. And it will read back what it just figured out. What it's doing is it's automatically adjusting the motor parameters based on the drive so that your locomotive runs smoother. I always do this on every locomotive first thing out of the gate, and it always, most of the time, I wouldn't say always, but most of the time it smooths out the drive considerably. One thing it will do though is generally it'll set this CV53 value really low. I've seen it very low. So you'll want to bring it back up to at least 140, but no more than 160. Going above 160 doesn't make any difference because most DCC systems in the United States don't run higher than 16 volts. Most are somewhere between 14 and 16 volts. If you're an HO scale, you're going to want to be up here around 140. If you're an N scaler, you might want to be a little lower, but somewhere around 140 is good. And your locomotive should run really, really smoothly after doing that. You can go ahead and write this now at this point and lock these in as defaults. It's not going to change all of these. It'll change up to CV51. So it'll change 3, 4, 5, 2, and 1. But that's generally good enough to smooth it out. If you need even finer smoothing, you can do this manually. This is the only way to do this, is manually. You can mess with this, but again, it takes a little bit of knowledge to know what's actually happening here. So I don't recommend messing with this too much. You may end up making your locomotive run worse. There is a motor overload protection in here. This was installed after Rapido had some issues with their motors, but I think they've worked all that out now. So I wouldn't be too concerned with enabling this unless you absolutely have to or you're told to by a manufacturer. And if your locomotive hums or has a buzz to it at low speeds, you can increase this to 50,000 hertz now, and it will, or it should anyway, get rid of some of that or most of that. The V5 decoders are much better at the low speed motor pulse hums and buzzes than the selects and the V4s were. So this generally is fine at 40, but if you need to, you can raise it to 50. And enable automatic parking brake I've never used, so I don't mess with that. If your locomotive has a smoke unit, none of mine do, that I run off the ESU decoders. But if you have one, this is how you'd set it. I'm not going to go through this because I don't use it. So again, this is one where you'll have to kind of figure this out on your own. But it looks like it's fairly self-explanatory if you have smoke unit. On sound settings, if you do have a steam engine and you don't have an external wheel sensor attached to your wheels to do the chuff, you'll want to change this to this line here, and then you'll want to play with this. And this is distance of steam chuffs at speed step 1. So you want to run your locomotive at speed step 1 in 28 speed step mode. You can set that with your DCC system. That's a system setting, not a decoder setting. Then run it at speed step 1 and then watch the revolutions. And as you count, you kind of see 4 chuffs per revolution. You'll have to adjust this. Distance of chuffs means that every, I'm going to put this to a normal number here. Let's say every, if we put it at 1.02 seconds, I'm going to get a chuff. I've found that for a vast majority of locomotives, this value will be somewhere between 40 and 80 or somewhere. Again, it's going to vary because of the driver size of your locomotive. And then CV58 sets the adjustment for higher speed steps, so 2 through 28. And again, trial and error. What I would recommend on this one is run the locomotive at the typical speed you're going to run it at, and then kind of eyeball 4 chuffs per revolution and set this number. I tend to err on the side that more chuffs are better, but at the same time, when you get too fast, if your typical running speed is 50, 60, 70 miles an hour, you might get the helicopter effect where it's just nonstop chuffing and it doesn't sound good. So that's where you want to reduce the chuff rate a little bit, bring it down so that you're still getting chuffs and you're not getting the helicopter effect, the whirring. If you run at a more slower speed, 20, 30 miles an hour, you might want to kind of err on the side of a little more chuffing, but again, not enough to get the helicopter effect. This is going to be all you need if you're running a standard steam locomotive like a 484 or a 282 or a non-articulated locomotive. Essentially, if you're running an articulated, you'll want to enable the secondary trigger and the minimum distance of the steam chuffs. This will reduce the secondary trigger by however much you set here from the first one. So this is actually not going to be for CV57. It's only going to be for CV58. So it's going to reduce the steam chuffs just by a little bit, so that there's a little offset, and that's what gives you the double chuff. Plus, it also helps with the simulating of the wheel slip and all that kind of stuff between the two engines on your locomotive. So if you have a big boy, a Challenger, a cab forward, anything that's articulated, you're going to want to enable both of these so that you get that double chuff plus the slipping. And then this is just the minimum distance of the chuffs overall. And again, you can play with these numbers until you get a value that kind of sounds right. Master volume, this is going to control all the volumes of all the sounds. So CV63, and it maxes out at 192, which is 150%. Don't know why they didn't make that 100%, but that's what it is. Fade out sound stuff I don't use. Brake sound, this is going to depend a little bit on momentum. So this is when the brake squeal turns on. So as you're slowing down to a stop, this is when it turns on. And these values are somewhat arbitrary. They don't really mean a whole lot, at least not to humans. So 20 just as a value. If you want the brake squeal to turn on sooner, increase it. If you want it to turn on later, decrease it. And then this is the switching off threshold. So this is where you want to time it so that the brake squeal shuts off right as the locomotive is stopping. And so that's where you would adjust that. So if you have a lot of momentum and your locomotive takes a little while to stop and the brake squeal turns off and the locomotive still moves another inch or half an inch or whatever, you'll probably want to turn this up a little bit so that it doesn't turn off quite as soon. If the locomotive is already stopped and the squeal is still going, then you'll want to reduce this so that it turns off sooner. And again, it's going to be very momentum dependent. The more momentum you add, then the more adjustment you'll have to make here, because you don't want your locomotive to be running 10 feet with the brake squeal on, because if you put in a lot of momentum and it takes forever for your locomotive to stop, your brake squeal is just going to sit there and squeal the whole time. So you want to make sure that you adjust this so it doesn't turn on quite as early. In this one, this is where a lot of people get confused. So sound CVs are not standard CVs. So you can kind of ignore what these mean, or ignore these names. This is just more for an internal decoder thing. So ignore sound CV1 name. It's not really a CV, it's a sound CV. So it's a different CV than a normal CV. So that's why I say just ignore it. It's not really relevant. What you're more interested in is the name here. So notch 1, this is actually how you change the notch points. So if you wanted to make it notch differently than what the default is, this is how you do it. If I want notch 1 to start at speed step 1, notch 2 is at 21. But wait, it's not really speed step 21. It is speed step 21 out of 255 speed steps. The decoder uses an internal speed step ratio of 1 to 255, not 1 to 128 or 126 like our DCC systems use. So you have to do a little math to figure out what this 21 really means and what notch that really is. And I think it's somewhere around 13 or 14 if I remember right, maybe 12. Anyway, it's somewhere in there. So you'll have to do a little math to kind of figure that out. How do I know this? Well, if we go to notch 8, you'll see it's at 136, which is above 126 or 128 if you want to look at it that way. So it's 136 out of 255. So you can play with the notch points. Let's see what they are here. Again, if you're using a proto throttle, you might want to change the notch points to make it match the proto throttle. The proto throttle is based in the 128 mode. This is based in a 255. So this is where you would change your horn type. So if you wanted a Nathan K5 or a Leslie S3 or whatever you wanted, what horn you wanted, that's where you would do it. You would do it here. So CV163 changes the horns. This sound file has, if we click on information, this sound file has 14 horns, 0 through 13. That's 14 horns. And this tells you CV63, 163 equals 0, 163 equals 1, so forth. It gives you what horn it is. Some of the horns may repeat in some sound files because they just don't have enough to fill the slots. But that's the horns. Bells are here. There's 6 of them. There's the auto bell timer. If your horn and your bell rings with your horn, some prototypes do that. You can turn that on or off as you need to. This is how long the bell will ring after the horn is off, in quarter of a second increments. And then there's 2 different brake squeal sounds, and then there's 4 different air dryer sounds, all set again with these sliders. See, air dryer, brake squeal. Here's the auto bell. This is the smart start. It says 3-minute cycle, but that's only if this is a 1. If it's a 0, it's off. Smart start is where the locomotive will start up, run for 3 minutes, and then shut itself down automatically. A lot of modern locomotives have this, and you can change the timing. So if we look back over here, here's the timing. So 1 is 3 minutes, 2 is 6 minutes, and so forth. I don't use it, so I leave it at 0. It gets a little annoying having your locomotive shut down, and then you're on to go, and it's got to start up again. So use it if you want, but I don't. So then down here, let's see, so let's look at horn. So again, you can play your horns. So if you change these 0 through 13 as we saw, and you click on horn, now you can preview your horn. I don't know. It kind of works. It's kind of annoying. If we change this, you can hear them all. So forth. I'm not going to go through them all because it's really loud. But that's how that works. If you clicked on bell, and change your bells, you can do the preview and you can hear all the different bells. Likewise, you can set all your volumes. Notice that CV32 equals 1, and then you have your main CV. So these now can go all the way to 255, which is 199.22%. Weird number, but that's what it is. And of course down to 0. So some locomotives, like if you had an oil burning steam engine, and for instance there's coal shoveling, well, that's not a relevant sound, so you would want to turn that off. So just hit 0, just bring it down to 0. It's easiest just to turn things down to 0. Like if you had F units, for instance, and you have an ABA or an ABBA, you don't want the horn and the bell and the Bs, so you just come in here to the horn and the bell, and you just set those down to 0. That gets rid of the horn and the bell and the Bs. It's kind of fun to say, horn and the bell and the Bs. Anyway, that's how that works. All these sounds have individual volumes. If we go down here to brake squeal, you'll notice that CV259 and then 32 equals 2. Back here up on the prime mover, CV259, 32 equals 1. So it's very important, because CV259 repeats here. It's very important you have the right index. These repeat 14 times in the decoder. So you want to make sure you're on the right one. Special options, DCC protocol has to be checked or your locomotive won't run. And then these two I check. Persistent function just makes sure that if there's a brief power interruption, that the lights will stay on, or they will come back on the way they were when the interruption happened, before the interruption happened. Speed, same thing, so your locomotive will resume its speed. Now these are only for brief interruptions, so it has to be less than about 2 seconds, or else it probably won't work that well without a keep alive. But the nice thing is you don't have to restart your locomotive again or turn all the lights back on. So the memory is a good thing to leave on. If you get an OEM decoder and you're not sure what the horns are, if you get the sound file from the manufacturer, and most, like I say, most manufacturers should give you the sound files, you can go into sound and you can click on the horn, which is sound slot 3, and it'll list all the horns if it doesn't give it to you in the information. This is kind of the secondary way you can find out what the horns are. And you can go to simulator, you can change SVs, change this SV9 to 0 through 13 like this, and then hit function and it'll play whichever one you want to play. So it's an alternate way to hear them before you write them to your decoder. So be sure to click simulator to get back out of it when you're done. Yes, that's the sound schedule for the horn. It's pretty easy when you look at it, but I won't show you. The prime mover is a little bit more complicated. If you want to look at it, you can look at it and be completely overwhelmed. Same thing with the bells. Now the bells work off of the auto trigger, so you have to just click on here and you can get to the bell list. And they work the same way if you wanted to go to the simulator and play them. You're now in SV10, so you'd have to find SV10, which is right here, and just change this from 0 to 4, it looks like. It's kind of weird that it's not showing a 5 there, but that must be the default. Anyway, 0 to 4. Simple. Manual notching is still in the decoder. I know some people like manual notching. Function mapping. It's down here on function 28. And the way it works now is listed here. You can still use F26 and F27 for manual notching, not manual nothing. You can you have to keep both 26 and 27 off first, and then turn 28 on. Once 28's on, 26 will notch up, 27 will notch down. I have not tried this, so I don't know if you have to turn 26 off first before 27 will notch down. If you're able to notch up with 26, leaving it on and then use 27 to notch down, that's a much better system than what they had before. But I've not tried it, so I don't know exactly how it works. But this is definitely better if you can leave 26 on, notch up once, and it'll stop, and then 27 to notch down. When you're done with manual notching, you have to turn all of them off. So 26, 27, and 28 have to be turned off. Here's that little more information on that load mode. You can read that on your own. And also coast is still in there, run 8's still in there. Again, if you do some tricks with 26 and 28 and also 27 and 28, you can use run 8 and coast. This particular file does have a low idle mode. If you press F24 to center the reverser, it'll go into low idle. And also does lock the motor, so make sure that you don't get confused there. 24 must be turned off to go to regular idle and then move. Also, function 15, which is probably the isolation switch, that will also lock the motor, and you have to turn it back. Yeah, isolation switch. So that will also lock the motor, and you have to turn that off before you're able to move. So there's a couple things in here that lock the motor: function 9, function 15, and function 24. So make sure that in these sound files you don't get confused. Your locomotive doesn't run for whatever reason. You might have one of these functions turned on. So check that first, and then make sure those functions are off. So then once you've done kind of mucking with all these tabs, go back to the or write it all, right here. Overwrite defaults, and then go back to the address tab, and then put your address in last. If you're running in a consist, again, you don't want that to be default, so probably a good idea just to do that again as not being default. If you do run in a consist, I recommend actually not using the LokProgrammer software for this. Do it through your DCC system. That way your system and your decoders kind of align. The information for the consist is stored on the decoder in an advanced consist, but by setting it up in the system will recognize it as a consist, and it'll work much better. And it'll be easier to break the consist and stuff like that. So the systems have a pretty good way to get through setting up and deleting consists, so just use your system. If you do it through the programmer, then the locomotive or the consist will show up as a locomotive on your throttle. It'll still work, and it's just fine to do it that way, but you have to be a little bit more knowledgeable in how things work when you do it that way. Specifically down here when you're getting into functions in consist mode. So you have to kind of go through your locomotives one by one and go, okay, my lead unit's going to need which lights and which sound functions. And then my second unit's going to need which sound functions and which lights. Generally probably no lights, but you might have some sounds you want to activate. And if you have a third one, or if you have trailing units down on the rear end of the train or in the middle of the train, you have to kind of set those up. So and that kind of works the same way even if you do set up the consist through your DCC system. But I just still recommend setting up consist that way, not through this way. If you want to do it this way, you just check the box, type in your consist number. Again, consist can only be 1 to 127. If you reverse the direction, then it adds your consist address to 128. So if our consist address in this case is 1, and I reverse it to run a locomotive in reverse in the consist, now it's going to make CV19 be 129. That reverses it. I know that was fast, but again, if you do this through your system, the system will handle it. You never have to know that. That's the beauty of it. One thing to note, in the consist mode, they added front light and rear light, but it doesn't work. Rear light still doesn't work. You can turn this off, put the engine in a consist, and go in reverse, and the rear light will still turn on. So this is still a bug that has to be worked out. I don't know. I don't know why they haven't fixed it, but it still doesn't work. You can still get around that by going into function mapping and deleting the rear light like that. But it also deletes it if you break the consist. So if you like your reverse light, then you have to go back in if you break the consist and put this back on. Not a big deal, but just something that you have to know. I don't really use rear lights, and a lot of my locomotives I don't even put them in, so it's not a big deal for me. But if you use them, that's kind of the workaround. So note that this doesn't do anything. If you do disable the front light, yeah, it will disable it in this mode. And then everything else, in my lead units I just leave everything on, and my trailing units I turn everything off. Not everything, I guess. Lights I turn off, obviously, but anyway, trial and error, play with this, and that will allow you to run in consist. And what this means is it's going to turn on it's going to turn these functions on when your consist is run from the consist address. Again, from the address 1 to 127 that you set the consist into. I know Digitrax kind of works that way. I don't know. NCE runs consist from the lead unit number, but again, these can still come into play, so be very careful there. And I think that's about it. So the last thing you want to do then is set your address, and then of course uncheck the box, hit next, and now it'll write the address, but it won't make it default. So now when you hit a CV88, it reverts back to address 3, and you can test it if you want. If you have a LokProgrammer or on your DCC system, you can set CV88 and it will reset the address to 3, but everything else we set in here will stay the same. That way you don't have to go through this all again, spend an hour doing this again. So that's the beauty of it. CV8 to 8 and hit write, and it'll write it, and your address will go back to 3. If you ever want information on your decoder, you can do this and then read it again. It requires a LokProgrammer. Sometimes it'll tell you how long your decoders run for, which is kind of fun. Sometimes the number you get back is not very accurate in hours and minutes. You're like, there's no way that locomotive's run for 100 hours or whatever. So sometimes the number doesn't come back very good, but at least it'll tell you some information about the decoder. It's also a good way to know if you have a bad decoder, just to come in here and hit read, and it'll, if this doesn't populate or you get an error message, your decoder might be bad. There's another way you can do it too. Up here in Programmer, Extended Decoder Informations will pop up this window, and you can read decoder, and it'll tell you what the decoder type is. Again, it requires a LokProgrammer. If this doesn't read, then your decoder probably is bad. That's a really good indication your decoder might be bad. So yeah, and then of course you can test your locomotive through the LokProgrammer. So if you have a long enough piece of track connected to your LokProgrammer, again, make sure that the track that's connected to the LokProgrammer is not connected to your layout or connected to your DCC system in any way. Not even on a toggle switch. Don't ever have your LokProgrammer track connected to your layout or on your layout or as a siding on your layout or anything like that. Have it on your workbench. Have it somewhere near your computer if you have to, but do not tie your LokProgrammer track to your layout. Bad idea. Do not recommend doing it that way because it's too easy to have a locomotive cross a gap, and now you're bridging your DCC track to your LokProgrammer track, and you're going to blow something. It's inevitable that something will fry. So it's best just to keep everything separate. It's fine to have a run program track on your layout for your DCC system, but don't do it with the LokProgrammer. Make sure the LokProgrammer is separate. And if you have a long enough track connected to your LokProgrammer, you can hit the go button, type in your address, type in your address first, and then hit the go button. And now you can play the horn, try lights, turn on the prime mover, those kind of things, and run your train a little bit. But again, keep it separate from your layout. Don't try to use the LokProgrammer to run trains on your layout. Unless your DCC system is 100% completely disconnected, so there's no chance of any issues. And again, I don't recommend running trains with the LokProgrammer. It's not really designed for that. This is more of a design as just a quick test, more of a, make sure everything kind of works test. It's not really designed to run your trains. So, and if you had turnouts, you could do that here. I've never done this, but it should work with ESU turnouts. I don't know if it works with any other brand. And I mean ESU accessory decoders. Now when I say turnouts, it's more of accessory decoders because they have to read back. So, actually these have to be connected directly to the LokProgrammer. So again, they would have to most likely be ESU accessory decoders to make this work. Anyway, now that this video is really long, if you just need to update the firmware in the decoder, you can do that. If it's already current, it'll tell you it's current, and then you don't need to rewrite it. You can read up on your LokProgrammer, see what version it is if you want. It auto updates, so there's really nothing to update on it. That's about it. There's really nothing else in here that's super exciting. One thing to note is this bar up here should always be blue. If it ever gets red, or if it ever hits the end of this line and turns red, that means that the file's too big for the decoder and it won't work. So if you've gone in here to the sound and you've messed around putting in different sounds using the template pack, also downloadable from ESU, then you might exceed the memory space of your decoder, and it won't write if you do that. So make sure that you don't overdo it. If you want certain horns and certain sounds, you may have to give up other sounds. So be very careful. Make sure this line always stays blue and it always stays a little bit under. You can also come down here in the bottom right hand corner and it'll show you how much free capacity you have, current capacity and free capacity you have for adding more sounds. So this one's pretty well almost maxed out. I could probably add maybe one or two more sounds to it, but anyway, just be really careful. Some sound files are really full, others are not. If you're not going to use certain horns, you can delete them. Delete them out of the list. If you're not going to use a certain sound, you can delete it, and then you can add something else you want. There's not a lot in the template pack that's really good anymore. This is really old. I wish ESU would update this with some of the newer sounds, but there's still some decent stuff in here you might want to add. If you're interested in a horn that's not in the template pack, and also not in your sound file, of course I would click on Bell. You can look at one of my previous videos where I show how to cross horns from one sound file to the other. So each sound file can actually act as its own template pack, and you can actually then cross horns back and forth. So if one sound file doesn't have the horn you want and another one does, you can open both and then just drag your horn over, and that's in my other video on showing how you can add more horns. You can add theoretically up to 255 horns, but like I said, you're going to run out of room. So as long as there's space in the decoder, you can add more horns. If there's horns in here you're not going to use, click them and delete them. If you want to add more, that's what I mean, I guess. Don't delete them just willy-nilly. But if you wanted to add something, then it's maybe a good idea to remove something. Kind of a one-for-one. That way you never have to worry about maxing things out. Anyway, that's my rant on that. So that's about it. There's really nothing more to know. If you do, actually I will show one thing really quick. If you do use an ECOS or a cab control system from ESU, the icons will populate into the system as well as some of the names. So we changed 12 and 7, but you notice that they stayed as they were by default here. If you want these to be accurate in your cab control or in your ECOS, you can come in here and change these. You can type in a new name, whatever name you want, and you can change the icon. There's several icons listed here. You can change it to a more appropriate icon. Dimmer was, like if dimmer here is icon 14, you could type in 14, it'll automatically change to that icon. Whatever. So anyway, that's just for the ESU DCC users. If you don't use ESU, this isn't going to mean anything to you. Also, if you wanted to, you can make a function momentary like the horn. So you click it, it turns on, and it's momentary. Inverted means that it's active when the function is off, and off when the function is on. That's kind of backwards, but anyway, that's kind of how that works. It inverts the function key. I don't know why you'd want that, but it's there if you want it. Okay. If anybody has any questions, comments, if I said something stupid or wrong that you know is wrong, it's inevitable that I said something wrong. Let me know in the comments. I'm always willing to do more videos. If anybody wants anything I didn't cover, wants me to go more specific, I can go one-on-one, send me an email, or send me a comment. I'll email you back. Whatever it is, we can discuss it. So if there's anything you want to know about ESU decoders that I didn't cover, or you have further questions, let me know. I will try to help you as best I can. I don't know 100% of how all this works yet, but I am continuing to learn about it every day. And this is just kind of an information on how I do things. Everybody's different. Set your decoders up how you want. So that's all I have. Hope you enjoyed the video. Hope I didn't put you to sleep. And we'll catch you next time on my channel. Rio Grande Fan, out.